Okay, well, Dr. Philip Calcott, welcome by us here at the SAT Studios. It's always wonderful to speak to somebody that drove all the way from where to be here today?
From near Falvater.
That is insane. I didn't know that. I thought you were like next door in Pretoria or somewhere like that. We're so appreciative that you are here. I think the topic of discussion today is something that people will find fascinating. But before we start with that, maybe you want to just tell people what you do. You spoke a little bit to me about what you do to people, and I think we need to share your contact details in the end, because I think there's a lot of churches that need to get you to come to speak to them. But please tell us what you do for a living.
Yeah, so my background is physics research, and I married a South African girl, and I always say she dragged me laughing and smiling to South Africa, and to her family farm, which is sort of in the depths of Limpopo, 34 k's to the nearest shop. And so the outlet for my science there is I do these astronomy shows, and my passion really is to introduce people to the glory of God through His creation, and use that as an evangelistic tool. And so we run science and faith camps where we really focus on the harmony between science and faith, which tragically is often missed by scientists and Christians sometimes. So we've got a game farm there, and we've got accommodation, and my wife's just resigned from teaching, and we see our vision really particularly developing these Christian camps. We've actually got a young people's camp coming up just in a couple of weeks, particularly focused on science and faith, but the whole Christian worldview thing really in general.
That's amazing. Today we're going to speak on quite an interesting topic, and a lot of Christians have heard about it, but they don't really know what we're talking about. We're speaking about the fine-tuning of the universe. Maybe you want to start us off and just tell us a little bit about what this is about.
Yeah, so this does get confused and mixed up with other things. What it's about is the fundamental constants that govern our universe and the particular values that they have. So there are certain key numbers that play a really influential role in how the universe behaves. So, for example, things like the masses of the elementary particles that make up the universe, the mass of the electron, the mass of the up and down quark, things like this. Those might be a bit esoteric for people, but other things that really matter are the strengths, the relative strengths of the various forces that govern our universe. So we've got four forces: gravity, I think we're all familiar with; electromagnetism, we've probably got some familiarity with; and then the strong and weak nuclear force, which we generally don't deal with. So for example, it turns out that the electromagnetic force is about 1 trillion times stronger than the gravitational force.
Oh my word.
But why? And this had, for a long time, puzzled and I think slightly annoyed physicists, that at the center of our theories of the universe, we have these arbitrary numbers that we've got no reason for, and all we can do is go out and just measure them and just pop them into our theories effectively. So that annoyed physicists a little bit, but about 100 years ago, it really started to puzzle them, because people started to notice that in actual fact these numbers, these fundamental constants of the universe, seem to be really rather surprisingly specific in terms of the ones you would need for life to exist.
Oh, wow.
So it turned out we weren't living in a kind of vanilla universe, we were living in a really highly fine-tuned universe. If you changed these constants, even very, very slightly in some cases, you would have a universe, but it would not be an interesting one. So for example, if you messed around with the relative strength of the forces, you could end up with it very easily with a situation where you didn't have any stars. Or you had stars, but they burned up much too quickly, or they formed much too slowly, neither of which would be a good situation for the kind of stable situation we have with our wonderful sun and for life. Yes. So it turned out you tweaked these fundamental constants ever so slightly, and you get basically a dead universe that cannot support life. And that's started to intrigue a lot of people, sort of why is that?
Why this? Well, in what way is our universe accommodating what you would call a habitable Earth, so it can accommodate human life specifically? Maybe you can tell us a little bit about that. Why is that?
So it's important to note the fine-tuning is not so much about the particular situation of Earth. That is also rather particular. There's something people call the rare Earth hypothesis that sort of talks about the peculiar situation the Earth sits in. This is much more fundamental. This is saying the fundamental constants of the universe that affect the entire universe are really strangely fine-tuned for life. So maybe let me give you an example. It involves a bit of a story, so excuse me if I go on. But it's to do with carbon. Now, and some people may be familiar with this one. So carbon is fundamental to life. The chemistry of the element carbon is completely unique. There's no other element that can do what it does. Basically, it's got 4 strong chemical bonds. It can use 2 of them to sort of grab another carbon, as it were, and create a long chain. And then the other 2, it can create side groups that go off, and so it can create all these amazing macromolecules that basically make our bodies. And also, not just our bodies, all life is built around the extraordinary chemistry of carbon. Yes. Nothing else can replace it. Okay, so we've got carbon. Great. But where did our carbon come from? Now, people started to sort of pick this together in the 40s and 50s, and in particular, a gentleman called Fred Hoyle, who was brilliant physicist, also an atheist to the end of his days, surprisingly, and he, surprisingly, based on what he discovered, but we'll come into that in a bit. So he started trying to look at the question of where carbon came from, and he realized that every atom of carbon in your body was made inside a star. We're actually, in fact, 90% of our body is stardust. It's quite extraordinary. There's a whole story there, and I tell it when I introduce people to the universe. But going back to carbon, and he looked at the process by which carbon was made inside stars, and there was a problem. It turned out that from everything he could see, there simply shouldn't be very much carbon in the universe. That's because it has to be made by this process called the triple alpha process, where basically you crash together the nuclei of 3 helium atoms, and that makes a carbon atom. Now, you can't do that simultaneously. The chance is minuscule. What you have to do is do it sequentially. So you crash 2 carbons together, and you make a new element, beryllium-8, and then you stick another, sorry, not 2 carbons, 2 helium, and you stick another helium on, and you get carbon. All well and good. Well, no, because it turns out beryllium only hangs around for a 10,000th of a millionth of a second. So you make your beryllium and bang, it's gone. You don't have time for your other helium to hit it and to make carbon. And this really stumped Fred, because it looked like it was impossible to make carbon. We'd got carbon. Something's going wrong here. And he thought about it, and he was a genius, and he worked out he could dramatically enhance the rate of carbon production if the nucleus of the carbon atom had an excited state at a very particular energy. It would create this interesting resonance phenomena, and it would basically drive the reaction a lot faster. Jesus. And he worked out what the energy should be. It had to be 7.65 mega electron volts. And then he looked in his nuclear energy tables, and there wasn't an energy level there. So I think most of us at this point would have said, oh well, obviously I got it wrong. Something else must have formed carbon. But he realized, no, this is the only way large quantities of carbon can be made. That energy level must exist. And it must exist at exactly that energy, pretty much. So he went away to the experimentalists and he said, look, I've got good news for you and bad news. The bad news is you're a really completely incompetent lot who've missed this energy level. The good news is I can tell you where it is. So Fred was notoriously unsubtle in the way he dealt with his colleagues. And they went away and looked for it, and they found, lo and behold, it was there exactly where he had predicted it had to be. Because if it wasn't there, there would be no life. And so Fred, in a broad Yorkshire accent that I won't try to emulate, he basically said, look, some super intellect, he didn't like the word God, has monkeyed with the laws of physics. This is a put-up job. The numbers that you calculate are so extraordinary, this can't be a chance occurrence.
There was a scientist working in the midst and amongst it.
The ultimate scientist was putting it together in the form it needed, not to just create a universe, but create a fruitful universe that could support life. So Fred's conclusion from this, so this is an atheist but a scientist, and he looked at the numbers and he said the only conclusion he can come to is, how he put it, some super intelligence. He didn't want to mention God, has monkeyed with the laws of physics. It's what I think he also called it a put-up job. This has been constructed to allow for a fruitful universe. So if that particular energy level of carbon was somewhere else, you would have a universe, but it would not be a universe with carbon. It would not be a universe that could support life. So quite an extraordinary conclusion, but on its own that would be, wow, that's really interesting, carbon. But as people went along, they discovered more and more of these incredible coincidences that suggested the universe was fine-tuned for life. And the deeper people have gone, the more of these crop up. So I don't know whether I can mention one more.
Please do.
There's one more that's really interesting because it's so extraordinary in its numbers. Again, it's quite a well-known one, so I apologize if people are already familiar with it. It relates to something called the cosmological constant, which is something that appears in Einstein's field equations. And basically it describes the energy density of empty space. Now you think if space is empty, why does it have any energy? Well, in quantum mechanics it does. Even empty space can have some energy. And the effect of the cosmological constant is to act as a repulsive force that actually drives the expansion of the universe. Now, this was sort of known about, but wasn't considered particularly interesting until a guy called Steven Weinberg came along in the 80s, and he looked at it and he worked out, this cosmological constant, it actually has to have quite a narrow range of values, or else the universe as we know it would not exist. So if it was too small, then the universe would collapse back on itself quickly. If it was too big, the universe would blow up before there was the chance to form galaxies. And he wrote a paper about this and no one really took any notice of it. And then 10 years later, people actually were able to do an incredible measurement. Saul Perlmutter got the Nobel Prize for it. They actually managed to measure this thing, and lo and behold, of course, it was within the range of values where Steven Weinberg had predicted. All well and good. But it turns out, as well as measuring it, you can actually kind of calculate it, or rather, you can calculate some of the contributions to it. And if you calculate the contribution from the electromagnetic force, the answer you get is 10 to the power of 120 too big.
Jeepers.
Now, 10 to the power of 120 is an insane number. For example, it's a trillion times bigger than the number of atoms in the observable universe.
Jeepers.
It's 1 with 120 noughts on the end. So this has been described as the biggest catastrophe in theoretical physics, the biggest mistake, as it were. And so people sort of thought about this, and how can this possibly work? And there's only one way it can really work. There are a number of contributions to this cosmological constant. So there's this massive, massive positive one. The way it must work is there must be some massive, massive negative ones that almost, but not exactly, cancel each other out and leave you with this tiny, tiny, tiny positive one. It's an analogy I sometimes use is the American trade deficit. America exports trillions of dollars of goods, imports a bigger trillions of dollars of goods, and every year has a trade deficit that's $1 trillion or so. Imagine the head of the Federal Reserve had a press conference one day and he said, guys, something extraordinary has happened. The trade deficit for this year is 1 cent. We sold this much goods and we bought this much goods, and the two exactly almost cancel each other out and just leave 1 cent trade deficit. It's a bit like that, except trillions of times more insanely accurate. So this freaks physicists out, and why is this happening? Why is the cosmos? But it has to be for life. If it wasn't so finely tuned as it is, we wouldn't be here today, and we wouldn't have a fruitful universe.
How do you get into the question of, okay, it's fine-tuned, therefore God exists?
Yeah, so basically, I think a fine-tuner, as you might call it, or a super intellect, is kind of the obvious conclusion. Now, there are ways to avoid the obvious conclusion.
And we'll discuss the multiverse, the atheist. I'll just skip that.
Yeah. Yes. So how do we get from there to God? Well, I think at first pass, it's the obvious conclusion that there's a fine-tuner doing the fine-tuning. That's at first pass. I think also when you dig into alternative possibilities, it actually still remains by far the most attractive conclusion based on the evidence. So it pushes you to believe in a creator. Doesn't tell you what sort of creator.
Yeah, for sure.
But it pushes you towards a creator.
Yeah, so it's sort of an argument that can be made for anybody that believes in a personal creator.
Yeah.
That is fair enough. Now, when we reflect on the fine-tuning argument, obviously people ask this all the time, but does life exist on other planets somewhere out there?
I mean, the honest answer is we don't know.
Yeah.
There are some reasons to believe not. So there's a famous thing called the Fermi paradox. So Enrico Fermi, another famous physicist, also a little bit eccentric, apparently he stood up in the cafeteria in Caltech or wherever he was working and sort of suddenly shouted out to everybody, "Where are they all?" And what he was referring to is the universe is so old and so vast that if life was a common occurrence throughout the universe, there should have been time for other civilizations to develop and become technological civilizations, become spacefaring civilizations. And even though our galaxy is so huge, for example, you still could populate it in a relatively small number of millions of years, basically, which doesn't seem to have happened. So this is put forward as a reason to believe that maybe life could be unique or very unlikely in the universe. So, I mean, the honest answer is we don't know. It's not a question we've got data on yet. But the Fermi paradox does suggest maybe we're unique. Maybe we're on our own from a scientific point of view.
What are some of the arguments against the fine-tuning argument?
Yeah, so lots of arguments have been proposed. Maybe I should run through 3 or 4.
That's enough.
There's actually 2 which get used a lot. So one is people invoke what they call the anthropic principle.
Yes.
So this is the idea that if life was not possible, we wouldn't be here to observe it. So of course, the universe is fine-tuned for life because we're here. And you think about it and I think, yeah, but no. It seems to be a bit of a tautology.
Yeah, for sure.
And John Leslie had a lovely analogy that helped, I think, expose the deficiencies with the anthropic principle as an explanation. And he said, imagine you have been detained in some land governed by a horrible dictator, and he doesn't like you, and he's going to execute you the next morning by firing squad. So the next morning you're dragged out to this, tied to this pole, and there in front of you, 100 marksmen, all aiming at you. Now, they're all good marksmen, so the chance of anyone missing is less than a tenth, and there's 200 of them. So
unless the Irish firing squad, they stand in a circle.
But they still might get you. So basically it's curtains, and you're blindfolded, and all 200 guns go off, and to your amazement, you find you're still alive. Now, you should not be surprised that you're not dead, because not dead people aren't surprised.
Yeah.
So that's what the anthropic principle is saying. But you still should be surprised that you're alive. That still needs an explanation. Why did they all miss?
Sure.
Maybe you had a friend on the inside who the night before came in and fixed all the ammunition so it was all blanks, something like that. But it needs an explanation. Just saying dead people don't get surprised doesn't cut it. It doesn't really explain it. So the anthropic principle is kind of true, but unhelpful. Doesn't give an explanation. Another explanation people will probably heard of is the multiverse. So there's various different multiverses, but the one we're referring to here is the idea that our universe contains possibly an infinite number of different regions of space where these fundamental physical constants could be different. And so if you've got enough of these regions and you've got enough sort of juggling of the physical constants, then a few of them, or if it's an infinite number of them, which is kind of confusing, will turn out to be just right for life. And so we're just lucky we're in one of those.
Yeah.
So that could be an explanation. It's not a tautology like the anthropic principle, but it does have a lot of problems. So atheistic scientists and Christian scientists put forward as one of their biggest objections to the multiverse the fundamental problem that it's untestable. So science, as a scientific theory, it's a problem because science is fundamentally about the measurable and the testable. And these areas of the universe are so insanely remote from us. They're utterly beyond our reach of ever measuring anything of them. So we're proposing something that's fundamentally untestable. And that freaks out a lot of very good physicists like Sabine Hossenfelder and Peter Voigt and these kind of people. So that's a problem. But I think there's more problems as well. So if one of them is inherent to this multiverse, you need a number of different things to happen, all of which are kind of controversial, or at least slightly controversial. There's a theory called inflation to do with the way the universe possibly blew up by a vast extent early in its life. And that's required for the multiverse. But not just inflation, you require a fine-tuned version of inflation. Ooh. So in that sense, you're just pushing the fine-tuning argument back a stage. Why did we have such a fine-tuned slow roll inflation? So that's a problem in terms of you're not really dealing with the fine-tuning problem. Then you've got to have string theory, which increasingly is unpopular with physicists because it's been going on for 3 decades and it's really delivered nothing. And a lot of people say it never will deliver anything. So yeah, people increase, and there's lots of problems. Peter Voigt, he's got a blog called Not Even Wrong about string theory, and that's the ultimate physics insult. If you come along with a theory, I might say, no, it's wrong. Look, there's an error here. If I come along and say, it's not even wrong, that's the ultimate put down. So he regards string theory as fundamentally a mathematical contrivance that doesn't have physical reality. Ooh. So that's a problem. And then finally, we've got this rather more esoteric, philosophical, you might say, problem of Boltzmann brains, Rudolph. Now the idea here is, Boltzmann put this idea together, that if you have a system, and you leave it for long enough, eventually that system will actually go through all its possible states if you leave it long enough. Ooh. So in principle, even if you have a universe that's not able to sustain life like ours, there's a significant chance over long enough time it might have a fluctuation that would produce a human brain, like on its own in the middle of nothing. And that human brain would momentarily be conscious, supposedly, if you believe consciousness comes just from the human brain. So, and you do the sums and you work out the chance of us being conscious as a Boltzmann brain is like massively more than the chance of us being conscious because we're in a fruitful universe. So why are we experiencing the full story of a universe that's fruitful rather than just the Boltzmann brain? So the multiverse would actually say we should just be a fleeting random fluctuation and not this rich universe we experience. So for all of these reasons, I don't think the multiverse is a good explanation, or rather should I say, it seems a lot less likely than the explanation of a fine tuner. So this is, Fred Hoyle put it very bluntly, that the numbers just really suggest a super intellect. But modern mathematicians and physicists love using this thing called Bayesian probability. I don't know whether you're familiar with it. So what it does, it's a beautifully simple way of what they call it updating your priors. So if you have a belief, for example, in the existence of God, some people that might be nearly 100%, some people it might be very, very small, doesn't matter. Bayesian probability gives you a way, when you receive new evidence, for example, of fine-tuning the universe, how should you update your previous presupposition, your previous priors? And basically, if you put the fine-tuning argument into that, it should always increase your credence that there is a creator God. Whatever you could, 1%, 50%, you should, after that new piece of evidence, I need to update my probabilities to accept that it's actually more likely that there is a God. So I think that's probably the best way of dealing with it, is to say there's no proof here. Science doesn't deal with proof, it deals with evidence. And what I would say, the fine-tuning argument gives us evidence from which we should update our previous assumptions. So we should re-examine the evidence for God, basically.
And maybe a conversation we can have in the future, if you're back in Joburg again, is, the whole question on, evolutionary biology, and did God create only in physical 6 days, or was it a long process of time? Maybe that's something we can look at. But
those are the really interesting conversations.
I would love to have that with you. I would love to hear what you've got to say. How do you get somebody from fine-tuning universe to the biblical understanding of who God is? And also another thing I think maybe you can help us with is, how do you defend your faith from this premise that you believe in this biblical God? Yeah.
So, I don't know if you know Michael Cassidy from African Enterprise.
I do.
He once described a bit of a process of apologetics he talked about jungle clearing. For some people, there are general obstacles to their faith, and we can come along and sort of hack a path through that jungle for them. And I think the fine-tuning argument can be used a little bit like that. Someone can come along and say, science has disproved God. And you can say, well, actually, in fact, did you know we live in a fine-tuned universe? What does that mean? And it can just create awareness, interest, and accessibility. People think, well, maybe I should consider the claims of God and Jesus and who you're talking about. So I see it in that sort of role. I don't think it's going to bring anyone to the Lord Jesus Christ on its own, but it might make them more open to considering the claims of Christ. So we don't have a gospel of the fine-tuning of the universe. We have a gospel of the cross of Jesus Christ, and that's where we've got to bring people to. But it might just make them more open to considering the evidence for the resurrection of Jesus, for example.
Yeah, and maybe in conclusion, what would be quite valuable is, a lot of people think, you've just spoken on the fact that when we look at the vastness of our universe, it all happened by chance. If I listen to you, I think I'm more convinced and leaning towards this was not chance. Yeah. And maybe just explain in this vast universe what difference that makes for how man sees himself. Because we've mentioned that if you look at the vastness of all of these things, and you feel pretty insignificant.
Yep.
How do you get somebody back to a feeling of almost significance and not being that small and feeling that you're that insignificant?
Yeah, well, that's a question very close to my heart, because I do this on a daily basis. So I do astronomy tours for people, and I take them out, and usually we're in a very lovely dark sky area. There's no light pollution. We put down mattresses and blankets and hot water bottles if it's cold, and get them to stare up at the universe. And I give them a tour of the majesty of the universe. And we start at Earth and basically go deeper. So planets, stars, galaxies. And by the time I've finished, I can see a lot of people are a little bit unsettled, because it's like, I'm so small, I'm so insignificant, I'm really feeling just like a tiny speck bobbing on this vast ocean of stuff. And at that point, I find it's really helpful to say, yes, you are small, but you're not insignificant, because the creator and sustainer of this vastness considers you significant. He has demonstrated in his own blood you're significant. He came to planet Earth. He didn't go to Beetlejuice, and he became incarnated as a human. That makes an extraordinary statement about how important you are. You're really the most important thing in the universe. You really are, because God has made that statement. And then taking it to mind-blowing levels, the creator and sustainer of the universe endured an agonizing, shameful death to enjoy a relationship with you. Wow. Then we're significant. So I have a little slide I put up when I talk about science and faith issues that for me is the core of it all. It's a picture of the Milky Way, the vastness of the Milky Way, 300,000 million stars, just one of 2 trillion galaxies. So that's in the background. And then superimposed on that in the front, I have Calvary, and it's both. So it's the creator on the cross. So it's the vast majesty of God, the one who knows everything, controls everything, has power beyond what we can even conceive of, and yet he's a personal God who actually loves you. And I struggle to fully understand, well, of course, we can't fully understand that, but dwelling on that creates an extraordinary sense of our significance. We are significant because God has made it so. He has demonstrated our significance.
Oh, that's amazing. maybe you can end off by just telling people where they can email you, where they can find you, where they can come on those tours and stuff like that.
Yeah. Well, if you can email me personally at pcalcott@gmail.com, or you can go to our website for our cottages, waterbergcottages.co.za. We have cottages in a lovely game area, and a lot of people come to see the stars because we're in a lovely dark sky area, and I enjoy giving them little tours of the universe.
Well, I would love to see that. Well, Philip, thank you so much for your time, and thank you so much for driving all the way
Pleasure.
and being with us today in the South Studios.
Absolute
Thank
pleasure.
you so much.
Absolute pleasure. Thanks, Rudolph.